I think this is probably one of the most exciting topics for me, at least, as a developer, but also as someone that still does a bit of research around LLMs. This is a topic that I've been, I think, involved from early days. So I have a lot of like takes about it, and ways on how you can use reasoning LLMs for like building LLM applications. So this particular session will focus mostly on some practical tips on how to build with reasoning LLMs, how to think about them, and what they are, and hopefully towards the end you have a good picture of that. And well, my hope is that at the end you have a few ideas on how you can go about implementing and using reasoning LLMs. I think that's kind of the goal for today. All right. If any questions do come up, please leave them in the chat. We have someone helping us collecting all the questions towards the end. I'm going to open it for more questions, but I'm going to get to answer questions. So I want to go through first the presentation. The content here that I have is a reasoning LLM guide. And I also have a code walkthrough and some examples I want to go through. Okay, so what exactly are reasoning LLMs, right? Reasoning large language models. Sometimes they're called large reasoning models. Some people call them reasoning models. They're different names for it, but we're all talking about these large language models that have been trained specifically to perform reasoning natively, right, out of the box. And it's an exciting idea because there are a lot of use cases that can benefit from this idea of like logic reasoning, thinking deeply about a specific topic and doing deeper analysis. That is basically what these models can do. And these would be examples of reasoning models would be like Gemini 2.5 Pro. It would be something like Cloud 3.7 Sonnet and O3. These are the more popular examples. There are a lot of reasoning models that have been published over the last, I would say, couple of weeks and months, but these are the main ones that people are experimenting with. So what I want to go through is some tips on how to work with these reasoning models, right? Where we are using them, some use cases that might be interesting. And again, hopefully you can gain some insights there and you'll be able to apply that on your own use cases. So I'm going to do a little quick demo just to show you at a high level what the reasoning model does, what differentiates a reasoning model compared to the standard chat language model. So I'm going to go and take this prompt here, and then I'm going to paste it within my ChatGPT here. So hopefully you can see that here. I think you should be able to see it. And this thing is by default now for me. Most of the stuff that I do on ChatGPT anyways is going to be like complex search, complex tasks, like some advanced analysis. So I have this model as default. But obviously these other models are like the standard language models that you can use for day-to-day tasks. So I'll have this activated here. And what I'm going to do is I'm going to paste this prompt, which is what is the sum of the first 50 prime numbers, generate and run Python code for the calculation, and make sure you get all 50, provide the final sum clearly. So there are a couple of things that the system needs to do, right? It needs to, do a sum of this. So it has to do some add operations here. It needs to generate some and run some Python code, and then it needs to do some calculation so that it gets 50, and then provide the final sum clearly. If you want to make this harder for the system, actually, what you can do is you can remove all of this and then just give it this question here. This is just to guide the system a bit more, just in case it doesn't know what to do. But I think it's a good test, and definitely you can modify this prompt to make it harder for the system. So what I'm going to do is I'm going to take this one and send this to ChatGPT O3. O3, I believe, is their flagship reasoning model from OpenAI. And then I'm going to send it out. You can also test, I'm not sure what's the availability. I haven't checked the updates on this, but there's also O4 Mini and O4 Mini High, which are other, this is the next step, right? O4 is going to be the next step. These are things that you can try as well if you have access to them. I'm going to open here Google AI Studio. Google AI Studio also has a reasoning model, and that's going to be this one right here. So the latest version, which is Pro Preview 0506. So I can select that. Again, I'm not sure what is the criteria for getting access to this, but if you do have access to it, you can try this out. I'm going to do the same prompt, and I'm going to show you what the outputs are. So right away, you see that this model is thinking, right? So this one is an experimental model, but it's thinking. So what does this mean? It means that it's leveraging some thinking component, right? This model can do extensive thinking before it responds, right? Before it sends you a final response. This is a little bit different from the standard chat LLM. So let's look at the actual thinking part here. Now you can see it says like, here's my thinking process for fulfilling the request. Then it goes through some steps, step 1, step 2, step 3, and you can see it has it in a nice format. And it has a Python implementation, then it has refining the Python code, then writing the Python code, then it writes the code, then it runs the code. So this is simulated, you can see it there. And then it goes through those steps. And then finally it says, okay, here is the Python code to find the 50 prime numbers and calculate their sum. So this is the code. Right? And then it has an explanation. So this is going to be the final response, right? So these are two different parts of the response that you get with reasoning models. The first part is the thinking process, and the second part is the response. And all of the reasoning models can do this. However, there is a difference when you go to the API, right? So if you want to use these models in the API, like if you want to use O3 or Gemini, it's a bit different. For some of them, you cannot even see the thinking tokens, which is a bummer because the thinking tokens are actually pretty useful, especially if you are debugging these models for your use cases. Anyway, so that's about to change. I think a lot of these companies are going to provide at least a summary of the reasoning part, because again, that's useful for debugging. So this is just the explanation. Then it says running the code produces the following output. Then it gives me, this is the final answer. This should be the correct answer right here. And then it finishes. So this one finished in 22.7 seconds, which is, I think, considerably really fast, because in the past, these models would take really long for this type of task. So let's look at the other one now. So this one took 13 seconds, which I think is also very fast. I mean, much faster than this one, I think. And you can see that it did its steps, right? It went through these steps. It's telling us what it's doing, right? It also is going to do some code, right? It has this analysis. It's generating the code. We ran that. Then this is the output. Then it says the sum of the 50 prime numbers is this. So definitely it took less time, because it actually did it in like in 2 steps, literally in 2 steps. You can see it here. So that's great to see, because you can look at the code that it ran as well. You can see right here. I'm not going to go through the quality of the code, but that's sort of the idea of what a reasoning language model does compared to the standard one. In the standard one, you don't get the steps, you don't get all of that stuff. It will just try to give you a guess based on your task. So that's what the reasoning models do. The reasoning models spend compute basically and tries to answer your questions based on its thinking capabilities, also based on any tools it has access to. That's the idea of the reasoning LLM at a high level. All right, so hopefully that makes sense so far. Yeah, keep the questions coming. I'm looking at the questions already. Love the questions, and then we're going to take some questions later. All right, let me just go back here. All right. So that's the basic example. Hopefully you have an idea now what it is. And now let's focus a little bit on, this is a developer session. So let's focus a bit on how we make decisions about what is the reasoning model that we want to use for our use cases. When we're looking for a specific model, there's so many of them now, right? Like we used to only have like the O1 or something like that, and maybe Cloud could do reasoning, but we have a bunch of them now. So the question becomes then, understanding their features, understanding their strengths, how can we compare, right? One comparison that I would do with these examples, first of all here, because both of them got it correct, but I would look at the steps it took, whether those steps are actually accurate. And then the other thing would be obviously how much time it took. This one took 13 seconds, this one took 22.7 seconds. Obviously, this might vary every time I run it, but that's something that I'm looking at, latency. Latency is going to be a big factor in determining what is the reasoning model that I'm going to go with. So what I've done here, I've prepared, well, this is something that's work in progress. I must let everyone know that. Something that I'm putting together because we do train a lot of developers, and I work with companies as well on some consulting engagements. And the first question, that's what they're going to ask. They're going to ask, what are the models that I have available? What are the reasoning models that I can use? What is supported? And let me tell you, information is pretty scattered out there. And it's not easy to figure out what is the model, even the models that are available today. So what I'm doing is I'm starting to put this information together here. And hopefully it's useful for developers. And obviously, work in progress. And what I want to do here is I want to sort of highlight the strengths of the new reasoning models, how they compare. So what I'm looking at as a developer, again, as I mentioned, what is the context window, right? What is the max output? How much you're paying? Cost is also very important. This one is for input. This one is for output, how much you're paying per output. So if you look at it here, this is obviously going to be one of the expensive ones, which is the one that we just used. And these are the APIs, by the way. I'm talking about the APIs when you use them via the APIs. So $10, $250 if you're using cached input. And then there is like this 40 for output. So you're paying a lot of money per million, right? Per million tokens. And you can see the difference here. Like, let's see, for instance, this one here, Gemini 2.5 Pro, like it supports function calling. It has structured output. That's really nice. Developers love that stuff. And then like caching as well. Caching is a really nice feature. And then you have like these chain of thought outputs. Like this is more about if you get the reasoning tokens as part of the output. Again, I'm talking about the APIs. And here you don't get it. So it looks like Gemini 2.5 Pro is a really good offering as a reasoning model. And I think, for instance, also like we have Grok 3 Mini, which is a smaller and much cheaper reasoning model as well. Well, I haven't experimented too much with this one. I've only used it to run some examples of search in my X account, but I haven't really used it via the API, but there is an API for this now, and you can check it out right here in the docs. So I'm putting all that information here. I think that's one of the advantages, that it's a lightweight model. Typically, when you're experimenting, obviously you want to use the best model. So I think Grok 3 has a long way to go. Probably Grok 3.5 will be great for reasoning tasks, and it'll probably be more comparable to the other ones like Cloud 3.7 Sonnet or Gemini 2.5. But currently, Grok doesn't have a model that can compare fairly with these ones yet. So that's coming. And then you have like the open version, right? So we have like the open models like DeepSeek R1. I think DeepSeek R1 really made a huge splash, and for good reasons, because it's an open model, right? Developers can use it, can tune it, and so forth, can use it for all kinds of things. You can take the reasoning tokens and you can continue to refine models, fine-tune models. You can do a lot of stuff with something like this. So I really appreciated the assets that were made available with DeepSeek R1. And then you have Qwen 3, which is another, I think is another Chinese lab. And this one is from Alibaba, I guess. Yes, Alibaba. Also, much cheaper model as well. If you look at the price, it's very cheap compared to the other ones. But this one also, there is open weights and stuff like that you can use. One thing I want to highlight here that has been an interesting trend, I think, recently, and this is very recently, I would say like the last month or so, is this idea of hybrid reasoning models. I have some comments on that. I think this is an interesting direction in terms of the progress around reasoning models. And I'll tell you why in a bit. And I'll tell you how this actually is useful for when you're developing applications. But this one does support this hybrid. I should have actually created a section for that. But anyways, I have it here as a comment. So this is a hybrid reasoning model. There is another one, I believe. I don't know. I think O3 doesn't have this capability. But Gemini 2.5 has that capability. Actually, Gemini 2.5 is probably my favorite model out of these, not only because it's cheap to use. I mean, Google made it as cheap as possible to use this stuff. So might as well use it. And they even have a free version of this model, an experimental model that you can utilize. And then you have Cloud 3.7 Sonnet, which also has this hybrid chain of thought. So a few of them do have it, but it's not all of them that will have it, okay? So I think that's a great functionality that you get out of these models out of the box, because it's not always you're going to rely on a reasoning model. It's not always you're going to use it. It's only in some situations that you're going to use those reasoning models. We'll talk about when you want to use reasoning models, the use cases where you want to use them shortly. So I'm going to talk about that in an upcoming section. Anyway, so I'm going to keep working on this. I think this could be useful for a lot of people. Let me know. Leave some comments here in the chat if there's anything that's missing here that you would like to see that can help you out, and I'll do the research and I'll put all the information here. But that's something that's work in progress. All right, let's go back here. So a big question that usually comes up with this topic or any language model in general is going to be the question that I get often is, how do I know which is the stronger of the reasoning models? So if you look at this document here, that is something that I need to add here. So yes, feature is one thing that I'm looking at. Features like function calling and structure output, because those are going to ensure that I can do a lot more with this reasoning model, and that I know that I can do some reliability work because I have access to structured outputs. But then the question becomes like, so which one do I start with? That's the big question that people have. I would say this is a hard decision today because like the prices, they vary a lot. The capabilities vary a lot with the models as well. The results that I'm seeing on the public benchmarks also vary a lot. It's not clear that, oh, this is the superior model. There are some benchmarks that you can use to sort of determine that to some extent, but I wouldn't really trust those public benchmarks too much. I wouldn't read into them too much. I I think you can still look at them and make a decision on what are the capabilities that you think make sense for your application. But I think this is something that you probably have to be experimenting on your own. And so this is why I think I appreciate a lot like having access to O3 from ChatGPT here and having access to something like this model here in Google AI Studio, because then I can just go here and I can just quickly test. The good thing is, while Gemini is not support, like Gemini APIs are not going to give you the thinking tokens, they give you here. So I can still go and test my prompts and check this. So long way to go, lots of progress to happen here. I think there's a lot of development that needs to happen still, or progress that needs to happen on the leaderboard front. But companies are working hardest. So here are a few resources that will help you, guide you into understanding what are the reasoning models, what's the progress on it, what are the stronger reasoning models. But again, as I would say, these leaderboards were not specifically designed for measuring reasoning. There are like specific reasoning, like math reasoning, visual reasoning, things like that exist out there. But typically what I want to look at is like a general benchmark that measures across the board or different things, right? Where you can do logical reasoning, can do visual reasoning, can do all of these things. So we can measure that. But that's hard to do and typically would involve you doing the effort on your use case. So let me open up this one here because I wanted to add some comments here on this one. Okay, so this one is, the link is there. I provided the link. This is the, I believe, LLM-as arena. This is a chatbot arena, which is a popular one that a lot of people use to determine which is the model that's on the cutting edge, the model that's leading, all the benchmarks. So as I was saying, right, they don't read too much into this. Like it could say that Gemini 2.5 Pro is the best model, but it can also be the case that, like something like Cloud 3.7 Sonnet is probably the stronger model on your particular use case. It could be that, and that wouldn't be surprising. Just based on my own experiments, I think that wouldn't surprise me a lot to see. So again, just take it with a grain of salt here. Don't really read too much into these things. But anyways, it's good to have something that's general. It's good to have something that's in the public here. And we can look at this and say, well, I think Gemini 2.5 Pro is, according to what a lot of developers are saying and their experience, that it is one of the stronger of the reasoning models. But you also have O3 here that's very strong, has a high score. You have other models, for instance, as well, like I would say DeepSeek R1, which is still in the top 10. I mean, we haven't seen R2, but I think R2 is probably going to be here at the top when it releases. And that's very exciting to see. We don't see Cloud in this list, which is, I'm not sure what's going on with Cloud, but Cloud is a very strong model as well. I probably have to click on view all. Let me just see here. Okay, so yeah, it went somewhere. Anyways, so you can look at, for instance, if you're working in vision tasks, can these models do reasoning? For some reason, this is not loading so well, like it's very slow. Yeah, I guess that's why it's in beta. So vision, for instance, what is the stronger reasoning model on vision? You can kind of get a good feel for that here. And then like if you're doing search, for instance, you have a search application. This is a nice addition to the chatbot arena. I really like this one. I work in search a lot. And you can see that Gemini 2.5 Pro grounding is, Gemini 2.5 Pro is the top model, I think, on all categories. It's not something you want to ignore. So web dev as well, you can see this is more for coding stuff. This one is the higher one. And now you see Cloud 3.7 Sonnet. Anything when you talk about code use cases, Cloud 3.7 comes up. And actually, this is my default model that I use within Windsurf and Cursor and some of those IDEs. So definitely it's going to be at the top. But that tells you that it's not just one model that's leading the way. So you have to look at the different categories to determine which is the model that's going to be the right model to use for your specific task. It really depends on the domain. So yeah, that's it's under development. I think a lot of these companies, they're still focusing a lot of effort on improving their reasoning models, and I'm very excited to see what happens in the next few months on this, and what is a model that's going to lead, in general, and is going to lead for all the different categories. So that's something where you can track that here. All right. Let me see where we are here. Yeah, I'm seeing some questions here. That's great. That's awesome. Okay. All right, keep them coming. So I think this is the fun part. This is, I think, what we discuss is, a bit of the theory, a bit of like places that you can go and check to make decisions of what model to use. Let's say at this point you have figured out which model you're going to use. Let's say it's Gemini 2.5 Pro. The question becomes, where do I use it? Like, I think I get that a lot. And, what I've done over the last few months is just spend time on this, like figuring out what are the use cases that this unlocks? Where should I be using reasoning models? Not for everything that I want to use reasoning models. And one way I figured this out, I think this is probably an interesting way. Probably haven't shared this before, but one way that I do figure it out is I actually look at the products. So I look at the products that are coming out from these, top AI labs like ChatGPT or OpenAI, right? They have released this product called Deep Research. And a lot of you probably heard about Deep Research. Very capable, can search the web, can produce extensive reports on pretty much any topic. And the model that powers Deep Research, for those of you that are not familiar with this, is O3. It was a variant of O3. So before O3 was actually released, or this version here, there was a variant of that was plugged into Deep Research. And that's when I knew, reasoning models are going to be huge, because like if you've tested Deep Research, you'll realize that it does so much things behind the scenes to be able to produce like really high quality reports. And that's the first time I felt like the outputs of these models are completely different in terms of, the quality of it and how extensive it is, right? And how accurate it is as well. And that had to do with that reasoning model. So I was quite excited when they said they were going to announce O3, or they're going to release it, they were going to make it available in the APIs and so on, because I knew that was going to unlock a lot. But how I figured, way ahead, where do I want to use? Where do I want to keep experimenting on this? I just waited for some product updates, and this one was one of those examples. So Deep Research is just it's a search agent basically behind the scenes. They're using some planning capabilities, and that's powered by the O3 variant of that model. And what that does, it plans, and then it kind of goes into a search. It has of course, the search plan, it executes the search plan, it gathers information, it can, backtrack, it can go in the loop, and it can do agentic things. And that's why the report is so good. So it's basically combining reasoning with agentic capabilities, which means the model can reason and at the same time can do like multi-tool calling. It can call models as it goes and progresses through that task. And that's very new. That's a very new capability. And you can see it from the outputs that you get with this, because you get to see, I don't have an example here, but you get to see on the right-hand side panel here, when you use Deep Research, all the steps that it's taking. I like that because that's where I knew that something big was coming. And so I asked myself, like, what insight can I use here? How can I be experimenting? And I don't want to wait for O3. I want to experiment with like the models that I have access today. And what are the use cases that it's going to unlock? So I think search is going to be one of them, like doing web searches. So that's where I started to experiment a few months ago, and sort of found out a few ways how you can leverage these models, to improve your applications. So the first one, I think the huge one, I know a lot of you probably are developing like agentic systems. I certainly am, and our teams are building this stuff every day. There's so much to explore here. Deep Research is a good example, as I said, of an agentic system that's powered by a reasoning model. And here what I'm showing you is an example, a very, very, very basic example of where a reasoning model can be used in a complex search system. Right? A complex search system would be you have a reasoning model that plans the search and then has another agent, and the agent executes that search. But in order for you to execute an effective search plan, you have to come up with a good plan first, right? And a plan would mean the actual search queries that you're going to send out to that tool, and that tool in this case would be web search. And so this is a good example of that, very basic example. And so that's what you're seeing here. So in this agentic system, that first part is so crucial. If you use a standard language model to do the search plan, I can tell you that that will not be great. Like the results will not be great. Maybe this part works great because you can use any model for this, but this specific one will not be working so great. And I want to mention an important point here. The only reason I was able to figure out that there are certain components where you want to apply these reasoning models is because the way how I've been building with these LLMs is very modular. Like, okay, so I have a refinement step in the application. I have a verification step in the application. I have a step that takes care of the query first and maybe do some augmentation on the query. When we didn't have like these native reasoning models, I was doing like chain of thought as well. I had a prompt that does that. So I was designing modular already. So it's easy for me to actually use a reasoning model in the development of my systems because I already was designing like that. And also for some of you that are probably not used to designing like that, I think it probably will be a little bit harder to understand that. But I think after going through all of these examples, you'll realize that, okay, it looks like this is like a common design pattern that I should be following. And hopefully I can convince you of that. And you can go and experiment like that with these reasoning models. So that's one example. If you have any questions about that, let me know here in the chat, and I'm going to take those questions there. I think one more comment here. The hardest part of this application is that it is an orchestrator in the sense that it's going to break down the queries into like subtasks, and it needs to figure out also on top of this, it needs to figure out not only like what type of searches, but how many searches it really do as well, right? It needs to search different kinds of sources, like academic sources, news search, web search, but how many of them? Do we have like 3 queries and that are web searches, and then so we need to have like 3 web search agents? So this part will figure that out, and this is why we need a very powerful model that can do that planning for us, and that's where reasoning models have huge potential. So let me jump into the second use case here. Again, this is going to be about agents. This one, I think, without focusing too much on terminology here, is an agentic RAG system. So these are systems that I've been building since early days of RAG systems. And one of the areas that I've been working on, this is way before, again, we had these reasoning models. I was already implementing these systems, like agentic RAG systems. And the way how I used to do these systems is, okay, we had function calling, right? These models can do function calling. We can, we have a system. So this is the little figure here. And so what I would do is every time I would get information from my vector database or my document store, I would pass that information along with the query to a reasoning chain. And this reasoning chain, what was it? Well, it was just manual chain of thought prompting. And again, as I said, if you have been developing over the last couple of years, since we didn't have reasoning language models that can do this reasoning out of the box, like you would just do chain of thought prompting. And that typically led to reducing hallucination rate, like it led to, giving more accurate responses and so on. So this definitely enhanced the performance of the overall RAG system. And this is why I consider it an agentic RAG system, because there is some LLM or an agent that's powered by an LLM that does the retrieval, right? Does the reasoning as well. It can search the web as well, and it figures that out on its own. It's going to loop through these different steps, and then finally it's going to give us a response. So in a sense, it's like a loop agent that's just looping through all the tools using function calling, and then it's going to produce the final response. So this is a very neat idea. If this is not something you have tried, I would recommend you go and search agentic RAG on the web. There's a lot of people talking about this. A lot of like tools are using this as a classic example of how you would improve a RAG system. So I definitely want to encourage you to do that. But yes, that's where you want to use reasoning again. And now what I did was, well, it was easy for me because I already built modular. So what I did was basically I replaced this reasoning chain was a chain of thought prompt, and then just replace that with a reasoning model. So this is basically, you could think of it as a reasoning tool that I was using in this system. And that just elevated the performance of the stuff. All I had to do was just plug out this one and plug it in the reasoning model, and that was it. So I'm more prepared in that sense to experiment with these reasoning models, understanding that they might change, the capabilities might change, and so on. So because I build modular, it's going to be one huge advantage to be able to incorporate these things easily. All right. And let me know if you have questions about that. Okay, I'm happy to answer more details about this. I know I'm touching this on the surface. If you care about this specific use case, if you think this is interesting, let me know. Let me know your questions. So this is right, I would say, up my alley because I've been doing evaluation with these models, since early days. So LLMs as a judge is this idea that you have a language model doing assessment or evaluation for you. So in that way, you can automate, basically an evaluation pipeline. So how do you use this? That's a good also application of reasoning models. So where you want to use them as well is, so let me give you an example of what I mean here. So let me just try to expand this a little bit more so you can see the chart, okay? This chart right here. So this is a very, I think, a relatively new idea that was presented in a paper recently. And I've been exploring this idea. And I mean, I have a lot of examples of this because I found a lot of success with this concept. So the idea is that you would have, for instance, a data set, right? You have a data set that you're using to evaluate your application. And then normally you would have a system prompt, right? The system prompt that's used for the application itself. And then you would normally run some predictions, right? And you can use any language model for this. Like you can use GPT-4o, any standard model would work for this. And then you would get some outputs and you will take the predictions, right? And then you will also take the evaluation data set as well. So you can incorporate the evaluation data set. And then, sorry, not here, not the evaluation data set, so just the output, the predictions. And so once you have the predictions from the data set, right, those predictions then classically, how you would do this is you maybe use a human to evaluate the outputs of the LLM, or you would have like an automatic metric. So depending on the task itself, you would use something like, I don't know, like precision for classification tasks. You would use Rouge for summarization tasks, and so on and so forth. But once you have those scores, right, now what you would do is you would take, so instead of doing that, like that manual effort, right, you would take an LLM-as-a-Judge, which is basically a language model that you're using that judges the outputs that you're getting from the, it's judging the output from the predictions that you got from the previous. So these ones, this one and this one, are different LLMs that you're using. Now, for this LLM-as-a-Judge, it was some time when I was using this, again, before reasoning models. I would always say and recommend use the latest, because you want to use the smartest model for the LLM-as-a-Judge component. You want to use the smartest one. And again, because I've designed modular, I can take advantage of that, right? I could just plug it in and plug in whatever model. I can use a separate model from a different provider as well. So use the latest and most powerful model for this particular one. So that's just a little tip there. Why? Because the LLM-as-a-Judge actually is a hard component to optimize. And the reason is because like it has a lot of biases. Like let's say you're using a scale out of 1 to 5. These models have a bias towards like higher scores, 4 or 5. They're too positive in that sense. They're 4 or 5 is going to give you, and it's not going to give you like lower scores. And to fix that, you probably have to give it some examples. So there's a lot of things that you need to optimize here. But once you introduce reasoning models, it really changes the game, because reasoning models, they're really good at looking at data, finding variance in data, finding the distinctions and things like that. And it doesn't matter how big the data that you're giving it, it's still going to produce something that's of higher quality than a standard language model. So that's really is the step that you would leverage, a reasoning model, this one here. And so there's another step towards this, right? Because it could finish here, it runs the evaluation, it finishes here, you have some assessment, you have some idea on how your application is doing because you have this outputs from this one. But something that you can do, which is really nice with the reasoning models, is that you can ask it to give feedback as well. So based on the predictions and based on the data set, you would tell the reasoning model, give me some feedback on, give me some scores and give me some feedback on the predictions, right? How this model is doing. at the end of the day, what we want to do with this system is that we want to optimize this entire thing here, this part here, because this is the core part of our application. This part here is basically our optimization system. This part here is our system that's in the actual application. So this is, you're combining different ideas, right? And you're combining the reasoning model. So finally, when you have the meta prompt, so this meta prompt is an interesting one because what you're doing is you're passing the feedback, you're passing the evaluation data set, you're passing the predictions, and all that information is flowing here. So this is another LLM call that you do. And what do you use there? You guessed it. You're going to use a reasoning model for this one because it's a lot more information coming in. It's predictions, it's feedback, it's the feedback scores, depending on what you're opening with this. It's more complicated, I would say. More complicated information is coming in. So you want to use a reasoning model. And this basically what it does is going to say, hey, you have the system prompt, and I want you to optimize the system prompt based on all of the outputs that I'm getting from here. And then if you have a threshold, if you satisfy a threshold, then you complete the process. If you don't, then we want to go in a loop, right? So now it becomes a loop. So then it says the output of your step would be to create an improved prompt based on the original prompt, and then it goes in this loop. You can set thresholds wherever you want. So this is very high level. Like there's a lot of little pieces here that I missed in the actual architecture of the system, but this is really, really powerful. This idea of using language models to optimize, basically it's like automatic prompt optimization. I think you have heard about this concept, APO. And this is the concept that I'm explaining here. This is the idea. So we've been using this way before agents, way before reasoning LLMs, and we struggled to optimize this part here because we just didn't have good enough models that can understand like complex information like this. So that's the idea here. And I think reasoning models are just excellent at this type of task. Right? Anyways, I'm seeing the questions. Keep them coming. I'm going to jump into those questions in a bit. Let me just go through. So this is a little bit different because most of the tasks that we're talking about here are going to be, like text-related tasks. But it turns out that, so at least what OpenAI has done, that's, I think, more cutting edge compared to the other models. But I would say it's OpenAI and Gemini and the Google team, I would say, because Google, their models can do video understanding, image understanding, so you can actually input different kinds of information there. But I think there's something very unique about O3. I don't know if you have tested it, but O3 can literally take your images or any image that you input. It can reason about that, about that image. And the cool part about it is that, so there's a lot of technical progress that happened there, because what it does is it's going to take those image inputs, right, image tokens, and it's going to put them as part of the chain of thought process. So it becomes very native to the chain of thought process, which means that it can reason about those images. And this is just for image, but can you imagine what it can do if you were to be able to pass information like videos and all kinds of like multimodal information, like audio, for instance, could be another one. Man, this really unlocks like what models can do. And I think this is the frontier. As we think about the next few months, these are the things that are going to be exciting to look at and how we progress with these reasoning models. So visual reasoning give us that a glimpse of that future. So I'm going to share this. I think you can access this example here. I ran this test right away when this model came out, because I got so excited. I was running on this task, this crossword puzzle that no model can solve it. Doesn't matter which one I tested. And for the first time, I can tell you, like when I ran this, I was like so impressed by the response, because it was 100% accurate, and there was no model that could have done this previously. So we cannot see the image for some reason. This is I don't know why I cannot see the image every time I load this. Let me see if I can see the thing here, the images here. Yeah, so okay, so I can see the images. This is great, but I cannot see the original image. So the original image is just basically this one. So it's going to analyze the image. It's going to think about that image, right? And it's not doing web searches yet, but it all I asked is solve this crossword puzzle. That's all I gave it, and I told it to solve it, right? So analyze the image. You look how it does the cropping of the image, right? It breaks the task down, because this is what a reasoning model does. It's going to break the task into parts. So it analyzes, then I don't know where this weird grid is, but anyways, it analyzes the image again, looks at one part. It's almost like how we would do it, right? As a human, you will look at assess the crossword puzzle, look at it like this way and this way. So it's doing those things. It's really unbelievable that we have a system that can do this. This is really powerful. So again, it does the some assessment here. Again, it analyzes the image again for some reason, and it looks at the dung part here, and then it does some code, right? So it has some code that it's running, and then it goes look closer at it because probably got confused about something. And then it's really funny to see all of this, but it's incredible that we have something like this today. So you can see all the different parts, right? It does a lot of that. It goes back and forth, back and forth, back and forth. By the way, like you may be thinking, this is very unnecessary. Why is this model looking so many times at the data? Why is it cropping things and doing this repetitive work? Well, I will tell you that these reasoning models are not perfect. Like they do tend to do this a lot. Like for complex tasks, they would do repeated, for instance, repeated outputs, like repeated like tokens as well. And we're seeing that that's the case here as well. But anyways, that's really interesting to see. Again, another code snippet there. Again, it analyzes the image. It does that back and forth, back and forth. And then it figures out, okay, I have a plan. And now I'm going to search the web. So this is the part that's interesting because this is a crossword puzzle, meaning it's online, right? And basically what I thought is this system is going to cheat because it's going to go online. It's going to look for the solution, right? This is, I think we've all been guilty about this. We will find solutions. We'll use something like, like Stack Overflow, find a solution for something like that. I think it's fair if the model does it, but I really wanted to see that's not what it did. It searched for something. It searched for like clues. So it did all this web search stuff for clues, like looking for websites that provide clues there. It turns out that there are like crossword puzzle like solvers. There's like a lot of different things out there. I learned a lot about this search. And it's just looking for clues. That's what it's doing. It's not trying to cheat in any way or trying to find a shortcut. Look at it, you can spend a lot of time on it. Then it goes back to the image. Then it goes back and forth, back and forth. I've never seen this before from an AI model and never seen this from AI system. So the first time I saw this, which was a few months ago when it was released, I was super impressed. And then finally, the most important part, it got it accurate. This is really unbelievable to have a system, like I said, that does this. And this is just the beginning of it, right? But I think this is really powerful. The way that this reasoning model can leverage, like these tools to analyze images, crop images, rotate images, do whatever it needs to do to the image. It can search the web intelligently as well. It can use the code snippets as well, can execute code, all of that in one go. It's really incredible that a system can do this, and it can do it really well to solve the task. This one took 11 minutes. So it was definitely challenging for the system, unlike other tasks that I've tested. So yeah, check out that example. You might find some interesting things there in the chain of thought, but I thought that was an interesting one. So that's the visual reasoning. There's a nice blog post from OpenAI as well. We can check out some more examples of how they have used the visual reasoning tool. So how much do I have? Okay, 15 minutes. And I was supposed to go through code and everything, but you see, this is such an exciting topic. Like I probably will not be able to go through code, but I will still share the code with everyone. Anyway, so these are the other use cases here. There's a lot of use cases that we have experimented with this. So just a few of them, I would say, like again, the LLM-as-a-Judge would fall under this category here. So if you want to find, unique relationships between information or data, that will be a great use case for. And there's a lot of complex data out there in the enterprise or wherever. That's I think a good space to experiment. Reviewing, understanding, debugging large code bases. We know for a fact that these models are really good at that. Specifically, those Cloud 3.7 and Gemini models are really good at code. Scientific tasks as well. If you're using deep research, you will know that this is great at this. Literature review. This one is interesting. I showed you an example of meta prompt. I went through some exercise on that. I think this is an excellent application because it does remove some of the human effort that you're going to put in optimizing your prompts for your application. Data validation as well. So like maybe there's some reliability issues with the data. And it's not just data validation, right? It's like code validation, all kinds of different kinds of validation that you may be doing. This multi-step agentic, the example would be deep research, a classical example of that, and so on, right? So we have more examples here. Yeah, so this is stuff that, by the way, if you're interested, we're teaching this stuff. There's a course that's coming here, I think literally next week, yeah. So this is going to be our first live course. And we're going to go through some more examples, actual code examples, applications of it, building things. Basically, what we're going to do is just build these things and show how we build them. So if you're interested in that, let us know, and you can check out the information there. So yeah, I'm not going to go through all the document. You can see there's this stuff, you can read through it. I mean, there's some interesting insights here that I've discovered just playing around with these systems. I provided the explanations there. And let me see if I can spend, yeah, because I want to go through the questions that you all posted today. I probably won't have time. Yeah, we might do a part two. We might do a part two for this because I think we're not going to have the time to go through the code. But anyways, if you want the code, let me see, where did I put it? Where is it? I put it somewhere, I think. Hopefully I didn't forget that. Where did I put the code? Nope. Well, that's really strange. Well, I need to add it. For some reason, I don't have it. Okay, here it is. Yeah, thank you here, Santeri. Yeah, so the code is there. There's a code example there. Let me see. Yeah, so I won't be able to go through that. But anyways, basically what I've done with this is notebook here. I've tried to go through all of these steps, how I think about reasoning LLMs, how do I apply, what's the flow that I use. And it's all detailed there with code examples, and it's using Gemini, but you can use all of those tips for any reasoning model. If you're using R1 or the O series, whatever you're using, you can use to apply. So what is the idea of it? So I want to show you this part here, because I think this is the most important part. Yeah, so this chart didn't come out so well. But basically what you want to do is you want to start simple, okay? Sometimes you even want to start with a standard language model for your task. You evaluate the response, right? You have some evaluation pipeline, you evaluate that. If you're happy with that, then you're done, right? If you're not happy with that, then you want to maybe, if the responses are too shallow, you want to enable native reasoning, right? So you want to use these reasoning models, and you want to start with a low thinking effort. You evaluate the response. If that's good enough, you're done. But if you're not, then you go into the other option, which is increasing to medium effort. Medium effort is going to be more costly, latency intensive, and so on. Typically, if you need more analysis, notice that the model is like producing responses. They're okay, but it looks like it missed some part, like it didn't go through a specific important step. Then you want to use medium effort. So the more you increase the effort that the model is doing, the better the performance is going to be. So that's what's called, I believe it's, there's so many names for this. Inference time compute, scaling law. There is like test time compute. There's so many names for this idea, and essentially what it's saying is that the more you increase, the more the model thinks, the better the performance is going to be. So that's the idea. And you get to do that within the API. So that's not available from here. What you can do is you can test maybe with this one. So high is going to be the option that you have. So let's say you have a task like this. You want to quickly test in the ChatGPT. You don't want to use the API. You can test with this first, then you can test with this, and you will see a very huge difference in the task. So this is how I would experiment, because you might have access to these two if you're a pro or a plus or one of those users. All right, let me go back here. So yeah, a lot of things that I mentioned here, like experience that I've had with it. How do you improve? How you think about latency? How you can improve that? How you optimize. First, you want to think about output quality. After output quality, you want to think about those cost and latency optimizations and so forth, right? So here I have it here. Overall, again, as I said, focus on accuracy first. You might be using one of the latest reasoning models, and then optimize for latency and cost. So this is an important point. I want to highlight this one. I won't go through this too much, but because of the timing. But I think while these models, and you saw with the crossword puzzle, it did really well for that task. It doesn't work so well for like real world tasks, and that's because the tooling part is not perfect, right? The tool calling capability of the reasoning models. Keep in mind the reasoning models have been optimized to do step-by-step stuff, right? It's very early days, I would say. That they have the ability to do tool calling, multi-tool calling, and more sophisticated types of tool calling. So that there's a long way to go in terms of tool calling capabilities. And then obviously you have multimodal reasoning. We saw the visual reasoning, but I think it is going to improve more. At least that's what the trend is telling for now. Let me see if I have anything else I want to highlight here. And that's going to be it. I'm going to take the questions now. Can you share the Google Doc, Santeri, and then I'm going to go through that. Yeah, sorry, but I couldn't go through the code. I think the code was going to be interesting to go through, but hopefully you still got value from it. I mean, please use this doc, share it with whoever you want, share with your friends, your colleagues, in your work. Share this doc. I think it could be useful for a lot of people that want to explore reasoning models. I think this can provide a good, like a good framework for how to think about these systems. And we will do a part 2. I'm going to promise you that here. I'm going to do a part 2 where we go through the actual code. And hopefully, that gives me time also to do whatever was more interesting for you. So leave us some feedback as well. What is the thing that you want to see? Like you want to see an Agentic RAG system. What do you see us implementing? We can only do as much because we only do these 1-hour sessions, but just let us know. We'll try our best to go through the example in code. All right, let me expand this a bit more here. All right. So I'd like to get your opinion on using MCP to help AI agents decide which reasoning model to use. To give you context, at the MCP level, defining several reasoning models that the agent can decide which to do. I love this idea. The reason I love it is because I think this is a creative way on how you can use the systems. So the MCP stuff is interesting because all MCP does is well, in model context protocol, it's about context, right? Providing more relevant context to your LLM application. And basically, you can connect tools or protocol to connect different tools. So you might use like a search engine or something like that as a tool that you can connect to this stuff. But reasoning as a tool is something that I've experimented with in the past before reasoning models were even a thing. So I know it's an effective way to use these systems, and know that we have a protocol that like helps this even further, or at least helps like augment the system in a better way. And it's more standardized. It gives me hope that these are things that people will be building in the future. Think of it like people will be building like these reasoning tools and these reasoning models and these systems, and you can just plug them in, right? Like they'll be great at some be great at visual reasoning. Some will be great at specific domains like math. Some will be great at science and so on. So I think it moves towards that direction. Like there'll be a lot of like tool releases, and some of it like will be reasoning tools. Some of it will be like maybe not related to reasoning, but other like capabilities. But I think in general, this is one direction I see. And so definitely if you're building agents, that's something you want to leverage. I specifically have leveraged them for my Agentic RAG systems, but agents in general, I think would benefit from something like this. So that's a great question. Let me see, I like your opinion. Yeah, so by the way, I just want to mention one more thing before I forget, because I did forget this, and actually I wrote it somewhere in the guide. The reason I like this idea is because I talk about those hybrid models. The hybrid models, they have standard response, and then they have like thinking response, and you can turn it off. You can turn off the thinking. But there's another better way to do this. So if you treat the reasoning part of this as a tool, and basically you can use any standard language model, and you can allow the standard language model to determine, based on some function call, whether to use that reasoning model, right? So if you provide it as a tool, which is the case for MCP, then basically you've sort of like optimized the system, because now it's like you're going to allow the model to decide on its own whether it needs to use it or not. It's going to use the thinking or not, because you have provided it as a tool. So I think that's a really interesting idea to explore. All right, so we have 5 minutes. Let me see, and let me go through some more of these. Yeah, welcome, Tim. I'd like your opinion view on which downloadable models I can run locally, which would give me 70% capabilities to develop AI agents locally. So I love this question as well. There's definitely a lot of there's a class of developers that are focused on building locally. I am one of those developers that love to build locally, like personalized solutions. But I think today, I haven't seen really good resources for this, if I'm honest. Like in this guide here, like this list, I've listed DeepSeek R1 and I've listed Qwen as 2 examples of open models, but those open models are pretty huge models. Like it's hard to load them, on a 1 GPU machine. Like they're huge models. So what I'm hoping for that happens in the future, and I already started to see this with some companies, is that we're going to get smaller reasoning models, right? Smaller, like maybe 3 billion, for instance, 5 billion, 7 billion models. Hopefully we see those in the next coming. I think we'll have a lot of those models in the coming months. And the great news, as I don't know if you've heard, OpenAI is wanting to release an open source model too. So that's great news for us developers that want to build locally, because I think OpenAI sees the potential of capturing this market of open, like open source developers and people building locally. So there's a huge signal, right, that this is a direction a lot of companies are going to focus resources on. So, but I think it's too early. I think OpenAI is probably going to unleash that, this kind of work, right, like from different companies. You're going to see competitors also start to put more efforts. If you want to check out an important work that happened recently on this small reasoning models that you can probably run locally, I think your best bet is going to be to look at this work, which I think, this one here. So Phi for mini reasoning. There's some interesting details there, like how you might optimize a smaller reasoning model using a bigger one. So you can use something like DeepSeek R1, and you can distill that model and you can train it. So it shows you all the tricks, right? What are the algorithms, how you use reinforcement learning to optimize a smaller system. So I've gotten a lot of questions like this because what people are interested in using these reasoning models for, it's not just locally, but they want to use smaller reasoning models that are cheaper, right? The latency wouldn't be too much of an issue. They want to have control over security and privacy. But we don't have a lot of examples of this yet. I think this is still very, very early days. If you look in the Hugging Face Hub, you'll probably find a couple of reasoning models. I just haven't found one that really convinces me, hey, there's something here. So I would say this is probably the closest, and this is from Microsoft, right? Probably the closest I've seen to a small model that does really well, that can potentially be run locally, and so on. So this would probably be my recommendation for now. Yeah, hopefully that makes sense. Let me go and check out the questions. Yeah, so is there any open source model having high reasoning capabilities? I think I answered this. Yeah, there are a few of them out there, but I would say R1, Quen are the only models, because they're large models that have convinced me that, have very good reasoning capabilities, and you should definitely be exploring those models. But I think they are quite inaccessible because they're so huge. I think there was a 32 billion, something like that, model that came out from Quen. But I'm expecting that, that number goes lower, because when we talk about open source, when we talk about running things locally, I mean, these things are resource intensive, right? And we need smaller models. We need something in the range of like, 3 to 10 billion. And so we're going to see that, I think, in the next coming months. And hopefully we get one from OpenAI that's, smaller, that we can run locally as well. So something that we can run on Olama or whatever you use to run your local models. All right. So when using multi-agent systems, can an agent be a tool wrap for other agent? Let me see if I understood this. Can an agent be a tool? Oh, yes, like for sure. I mean, so I think that's the idea that I try to explain here, although this is a very basic example. Let me go back here. So this is a very basic example. So basically this, by the way, can be an agent itself. So this can be an MCP, like you can use MCP for this. So you have one retrieval agent, and then you have another agent that's maybe doing tool calling, and then you can kind of go deeper here. So you can make this have like different reasoning models, for instance. You can connect more things like that. So it'll be like one agent calling another agent and so forth. So this will be like a multi-agent system that has more capabilities of tool calling, but then you have a specialized agent that does the tool calling itself. So definitely I would want to implement something like that in this one, but there are other areas you can explore on that too with that idea. In LLM-as-a-Judge, we're using one or two LLMs. So, well, LLM-as-a-Judge, like I said, one LLM, so you want to keep this separate, right? So one LLM is going to do the predictions, which is going to take care of the core, application. And then you have this evaluation component, which is the LLM-as-a-Judge, which basically is just going to evaluate or do some verification on the predictions that particular LLM is doing. So basically, it's two language models. And as I recommended, language LLM-as-a-Judge, you want to use a more capable model. So the reasoning model is a perfect, I think it's a suitable system model that you want to use when you're using LLM-as-a-Judge. So that's what I tried to explain in that example that I gave. A reasoning model is also multimodal or can be applicable to image. So currently we can add into image, as you saw, there is O3 that you can do image, but I haven't seen one for audio. That would be interesting. If it can modify audio, if it can like change, I don't know, like the beat of the audio or something like that, that would be interesting because you can unlock like creative tasks. But so far I haven't seen anything like that or anything for video, for instance, as well. But definitely that could be an interesting one. Okay, so how React framework is used in any reasoning LLM. So, the React framework is an interesting one because do I have that there? I think I have it there. So let me just answer this one quickly. This will be the last one. I don't have it here for some reason. I don't have it here. But basically what React is, and I don't have an example of that I can use. But basically React is I consider like a prompting framework. When that got introduced, you're basically using chain of thought prompting behind the scenes. Like if you look at the actual prompt that powers the React framework, it's basically chain of thought. That's when we didn't have these reasoning LLMs. And basically what it did was like there was a reasoning part and then there was an act part. And the promise of that is that you can use the language model to first reason about the data, right? And then take action. And so the actions would basically be tool calling, which is what we have today, right? Tool calling, call the web search, call whatever tool. So the reasoning part is going to do the reasoning and the planning, and then the act part is going to do like the tool calling, set up the searches or the inputs, and then call the tools and get that information, and then it will take that information, then kind of process it, understand it, and then produce a response. And it's such a powerful idea because I think this is what started all of this agentic revolution. I think this is one of the first times we saw that you can use a language model which wasn't a reasoning language model. Just so you know, like this is the history here. But you could already do that, and so this really unleashed all of this work on reasoning. This is the first time we saw like a system can do really well on tasks because it can use the tools in a very intelligent way. So now, basically, what reasoning models are going to do is going to maybe package everything. Do the reasoning and do the tool calling in one go. And this is what you saw with the example that I showed you with O3, right? Is doing everything, packaging everything, all the capabilities in one go. And all you care about is just the output. All of this stuff, you don't really need to see that, right? So that's kind of the future. And by the way, this act part to me was a little bit confusing because, so what does it mean to act? When we talk about agents, act is about taking action in the real world. But then in this case, it wasn't that. Basically, what it was is like it takes an action, but the action is so basic that it's just going to do like a web search or something like that, and that's pretty much it. But I think when we're talking about like action agents, that's a whole different ballgame that we're talking about. Like agents that can act for you, make decisions for you. So I made a comment on that here because I think that's an important topic, and that's probably the future where things are headed. So like systems that can make decisions for you and act for you on your behalf. So like, let's say you were using deep research, you were asking it to do some report, and then like deep research realized, there's a mistake here. I need to take action on this because you gave me some notes and I need to take action. Maybe you need to go do another search or something like that. And so it does this in an autonomous way. I think that could save a lot of time. That could be more efficient as well for the work that you're doing. But models cannot do that today. Agentic systems are not capable of doing that. So the question becomes like, how can we build systems that can act in the real world? Like it can perform a search, it can perform, purchase, traveling tickets, whatever that may be that you're using these models for, set up an entire event, something like that. I think it's not there yet. But we're starting to see companies like really starting to push that. And the thing that's going to unlock that, well, guess what it is going to be the ability to do like robust tool calling, which is what I mentioned earlier. And those reasoning LLMs are going to be, I think, the huge unlocker for that. So I will leave it at that. I think that's just food for thought there for you. Unfortunately, I couldn't go through the code example, but we'll do a part 2 for sure, because I think there's a lot of interest in this. And please give us some feedback. Let us know what you want to see. Let us know the example and the code examples. I'm happy to put the examples together, but it'd be great if there is a specific use case that you want us to go through. There are many examples here. Just a last note. There's, in the academy, this is what we teach. Like we teach, we have all these courses, we have a community, we have events, we have office hours. we go through all of this stuff like every week, right? And you have these courses where you can learn about this stuff, how to implement them in code, how to implement it with no code tools if you don't have a coding background. There's content for all of that stuff. So many use cases that we cover in these courses, from like basic prompt engineering to more advanced prompt engineering to building advanced AI agentic systems and so on and so forth. How you use reasoning language models, how you make sense of them, like the code examples, the tips, right? How do you combine future prompting with chain of thought prompting, and how to, all of these ideas are things that we discuss in our courses. So if you're interested in learning more, just check that out. There are some links here. I provided some courses that I'm recommending.